There are three blocks. This one has a largest mass 3m, then 2m, and then it has a smallest mass. And in this question, you see that these three blocks are pulled by this force F towards the right. Means that this is a system which is accelerating to the right, and the coefficient of friction is same for all of them because all of the blocks are experiencing the same rough surface. So the coefficient means that the coefficient of dynamic friction or the kinetic friction is same for all of them. Now since this surface is horizontal, that's why the upward and downward forces will cancel out each other. Those are equal. I'm talking about the normal or the contact force and the weight. So that's why you would see that the main forces on all of these blocks is, I'm showing this frictional force which will experience or which will exert on all of these masses of the different magnitude. Okay, so in this question basically you have to find out that which string must be strongest. Now there are three strings, string A, B and C. Which one will be most strongest? So I will give you two solutions. One is a conceptual, but the other one is also very worthful mathematical explanation. So don't skip the video. So what is the strongest? Obviously the string C must be strongest. Why? Because it has to bear the total combined mass of all of these blocks. All right, so that's why it should be C must be strongest because it have to pull the total mass of 6m. 6m, and that's why you can see I have shown it especially like this visually, so you can see it is the strongest rope or the string, whereas this is the thinnest because it have to just accelerate the 3m, although the acceleration of the whole system is same. Why it is same, I quickly tell you, because all of the internal forces are balanced. For example, the tension at this point and tension this one are balanced, are cancel out each other. Tension at this point in this string B and this tension are both same, as well as the normal force and the weight, its normal force and its weight, its normal force and its weight, these are also balancing each other. So overall what we see that this is the frictional force and this is a kinetic friction. So can I say it is, because we know it is always mu Fn. So basically I'm now going towards the next the mathematical solution of this question. So this, can I say it is mu into 3 mg, because 3 mg is the weight. All right, so mu 3 mg is the frictional force exerted on this block of mass 3m. And on the same basis, can I say it is mu into 2 mg? Why 2 mg, dear students? Because 2 mg is the normal force or the contact force, which is equal to the weight of this block. In the same manner, this force, the frictional force, is mu into mg, which is smallest. Right, so now I want to make equations. With the help of the equations you can compare in which string the force will be maximum. Okay, so let's start. So let's start from string A. Okay, now for the string A, you see on this block how many forces, especially on a horizontal, basically because it's accelerating horizontally. So this is a force, I'm calling it Fa, whereas this is a frictional force, that is 3 mu mg. 3 mu mg. So it means that if I want to find out what is a, first of all, what is the sum of all forces along x-axis or the net force, so that is Fa, the force in a string A minus frictional force 3 mu mg is equals to 3 ma. Okay, dear students, with the help of this equation I can find out Fa. All right, so that is 3 ma plus 3 mu mg. Okay, at the end of this video it will give you a very good insight of this whole question, because we are driving it. That will help you in your FRQ portion as well. So now for string B, okay, so look at this mass 2m. This is a mass 2m. On the horizontally towards right, we see this is a force FP. Okay, so this is a force FP, whereas on this side, dear students, can I say it is a force FA? Because it is a reaction pair. This force FA is a reaction pair of this force, okay, which was accelerating 3m. So what is a net force for this? So net force will be Fp minus, or sorry, don't forget to include this frictional force, which I have already mentioned is mu into 2mg. So when we will make equation, right, so this is the net force, the force horizontally rightward minus the sum of these two forces, which are adding up into each other, 2 mu mg, is equals to 2ma, right? These are all the forces which are horizontally actually accelerating the mass 2m. So if you take it on the other side, so it will be 2ma plus fa. Look at this. Fa, the force in a string A, is directly added into this expression to give the force in the string B. All right, so it means and 2 mu mg. It means, dear students, it is obvious now that the force in the string B is more than the force in a string A. All right. So now, just last thing for string C. This is mass M, on which we see this is a largest force. In fact, you will see, because this rope must have a largest force because it is accelerating the whole system. This is a frictional force mu mg, and this is a force of tension in this direction, and that is, don't you think this is Fp? Once again, I would say the same thing, that this force is a reaction pair of this force in this string. Okay, Newton's third law. So once again, we will repeat the same procedure, that the Fc minus into, I will add these two forces because these are in the same direction, is equals to ma. So dear students, you can see that Fc is equals to ma, which results that the force of tension in the string C is more than the force of tension in the string B, and that is more than Fa. So which supports our same answer, but this is a whole mathematical explanation. I hope you like it, and our answer is option C.